Well, just when you thought you were going to get away with having a sub and not having to see me today, bam! I'm right here in front of your face. Okay, so the reason that I didn't want you to just write down the notes without me lecturing is because there's some really important facets to some of these slides, and I need you to get the emphasis on the notes today over minerals. Okay, so we already covered this page, how the elements are the basic building blocks. That's all you need to know. We've talked about atoms a little bit already, specifically the energy levels, protons, neutrons, and isotopes. So if you missed the notes, which most of you were here that day, but in case you missed the notes, in the nucleus of the atom, you will find protons, which have a positive charge, and neutrons, which have a neutral charge. And then these purple things right here are going to be energy levels, which are also called energy shells. And that is where the electrons zoom around. And electrons have a negative charge. And so the protons and the electrons will always be the same on a neutral atom because they need to balance out where it has a neutral charge. Okay, so we've already talked about isotopes, but just to go over it one more time, isotopes are elements that have a different number of neutrons than the basic element you would find on the periodic table. Examples being carbon-13. Carbon-13 has 13 neutrons in its nucleus, and so that's why it's called carbon-13. Carbon-13 is the only isotope that we really use in science that is not radioactive. All the other isotopes are radioactive, and we use those for radioactive dating. More on that later. Okay, so we finished off right around here where we talked about how the properties of a compound are different than the properties of the individual elements that make up that compound. And the example we used was sodium chloride, which is NaCl if you're looking at it on the periodic table. Okay, so the reason that this is, obviously, is because last time we talked about how pure sodium, which is just Na, is explosive in the presence of water. And we watched some YouTubes on that. And then also that chlorine is really toxic and can kill you, especially like chlorine gas is mainly what I'm talking about. But for some reason, when sodium and chloride bond together, they make table salt, which is obviously what we season our food with. And so the properties of table salt are much different. They are neither explosive nor a toxic gas. So a lot of our compounds are going to operate that way. An ion we didn't get to spend a lot of time on. It's down here at the bottom of this. That is something like an element or a compound, usually a compound, that has a positive or negative charge. It's either gained or lost an electron, so that compound is charged. We won't get too far into that this year in geology. Okay, so these are the three types of chemical bonds that we are going to be talking about. Okay, there are more bonds, but these are the main ones. We're going to be talking about ionic bonding, which is where you give away an electron or receive an electron. Covalent bonding is where they share electrons. And then, of course, metallic bonding is where metals share electrons. Okay. Okay, so the definition of a mineral. These are huge. And there's actually a sixth one that I'll add when I get back from this meeting. So in order to be categorized as a mineral, a lot of you were asking me, well, I don't see any difference between a mineral and a rock. Well, here are things you have to be considered a mineral. You have to be naturally occurring. Okay, this cannot be something that is man-made. It needs to be naturally occurring to be truly categorized as a mineral. It has to be a solid. It can't be a liquid or a gas. It has to have an orderly crystalline structure. And we're going to talk about some of the more typical crystalline structures that you see in nature, or specifically to certain minerals when I get back. They have to have a definite chemical composition. When I say this, when I give you the compounds, you will see that those compounds are always generally the same. Okay, so that compound will always result in quartz, or this compound will always result in calcite. And that's all I mean by definite chemical composition. Yes, number 5, they are inorganic. And if you haven't taken chemistry, which a lot of you haven't, and some of you are in right now. In order to be considered an organic molecule, you have to have carbon bonded directly to hydrogen. Okay, a lot of people say organic is just carbon, but that's not true. Let's look at carbon dioxide, for example. That is an inorganic substance. So to be truly organic, you have to have carbon bonded to hydrogen. And so for minerals, none of them, well, I shouldn't say none of them, generally almost none of them are organic. So they're all inorganic. They do not have carbon bonded to hydrogen. Okay, definitely need to write this down. This is how minerals form. You've got a couple of different ways, okay? Minerals are awesome in a lot of ways, and we're going to look at some extreme ones when I get back. But for one, crystallization from magma is a big one. The faster something crystallizes, the more it's like the texture of glass. Okay, and the slower something cools, especially from magma, the larger the crystals will be. So granite, we'll get into this when I get back, because this is actually really cool. If you've ever touched obsidian, it's jet black. It looks just like glass. It cools super fast. Okay, to precipitation. When I say precipitation, when I'm talking about salt, think of not precipitation like it's raining or it's snowing, but in science there's this thing called a precipitate. And a precipitate is a solid that falls out of a liquid. So if I take a petri dish full of seawater or salt water, the water will evaporate and the salt will precipitate out of that liquid. And so that will eventually give me crystals. That's why they call it precipitation. 3, pressure and temperature. Prime example, diamonds. Okay, anything that is under immense pressure by the earth. Okay, you putting something under pressure is not enough pressure. So it would be pressurized within the earth. And then, of course, temperatures, high temperatures from the mantle, which is where a lot of the magma exists. Okay, hydrothermal solutions. Hydro meaning water, thermal meaning hot. So that just means hot water solutions. Okay, so here are some pictures of crystallization from magma. We'll talk about this later. Okay, so mineral groups. There are several, I want to say 6. There are 6 mineral groups. So the biggest one is silicates. Okay, this is your main mineral group. So it's got silicate and oxygen together, and it makes what's called a silicate oxygen tetrahedral. So silicon is half of it, oxygen the other half of it, and then a tetrahedron has 4 different sides. And I'll show you pictures. I might have a picture on this actually. But definitely this is the main, this is on your test, this is the main category of minerals. You need to burn this in your brain. Okay. Here's a picture of the silicon oxygen tetrahedra. Okay, so the way it kind of looks in 3D is that, where's my mouse? This one sticks straight up into the air, and then these 3 work more like a tripod. Okay, so that's the tetrahedra. It's got 4. That's what tetra means, 4. And then hedron is this shape. Okay, so when it forms a tripod and 1 sticking straight up, that would be our hedron type shape. Okay, so here are silicon oxygen chain sheets and 3-dimensional. So here is a single tetrahedron, right? And then a chain, they come together. And then double tetrahedrons are cool because they make these little circle-looking things in the middle. More on that later. Sheets, as soon as we get more and more sheets put together, we make a 3-dimensional network. And this is what our actual mineral is going to build to look like. But if you look under a microscope, you can see the sheet shape. So we'll try to do that later. Okay, here's our second group, which is carbonates. These are things that contain carbon, okay, but are still inorganic, meaning it's not bonded to hydrogen. Okay, so it's carbon and oxygen and metallic elements. Just write it down. We'll get back to it, okay? And then oxides, of course, things that contain oxygen. But the oxygen has to be bonded to 1 or more elements in order to be considered an oxide. Typically metallic type things on your periodic table, typically metals. You can pause this if you don't have enough time to write it down, but we'll keep going. Okay, and then 4, 5, and 6. Here we go. 4 is sulfates and sulfides. You don't have to know the difference. You just have to know that they contain sulfur. Sulfur is that thing that smells like rotten eggs. Sometimes we have sulfur in our water. If you turn it on your sink or something and it smells just awful, that's sulfur. If you've ever been to Yellowstone and gotten near the sulfuric ponds or the sulfur vents, you'll know exactly what I'm talking about. If you find it in nature, it's really, really bright yellow, like highlighter yellow. And we're going to look at some rocks and minerals when I get back. So this is one of the most amazingly colored minerals. Minerals are typically very colorful, whereas some rocks are not. So that's another difference. 5 are halides. Halide is a word typically meaning salt. Okay, and so halides are minerals that contain halogen ion, which means a charged molecule or a charged compound, plus another element. But typically we use the word halide to just mean salt. There is a mineral called halide, and it is just salt. It's really, really salty, though, so it's not like table salt. It tastes more like sea salt. These are the types of things you would put in like a salt block to give to cattle or deer or other things like that. 6, native elements. These are rare, but minerals that exist in pure form. So this would be like pure copper, for example. That's your typical native element. Okay. Here are pictures of sulfide. Remember, these are the ones that contain sulfur. The one on the left is pyrite, which is like fool's gold. And the one on the right looks like biotite or magnetite, but it's hard to see from here. Here's native copper in its pure form. It always typically makes that sort of weird shape or liquid looking material. It always looks like that in nature. Color. Okay, these are the properties of minerals. Write that down. Properties of minerals. Okay, because there are several properties of minerals and they are on every quiz and every test in this unit. So write it down. Property number 1, color. Okay, so this is not at all a good indicator to identify most minerals by, because there are lots of different minerals that all have the same color. And then there's lots of different colors for one mineral. So quartz has like 3 or 4 different colors that you can find it in nature. And then when you're finding just the white version of quartz, well, there's like 5 things in a typical mineral box that are all white, just like that. Same thing with grays and blacks. There are tons and tons of minerals that are gray and black. So color is rarely a good indicator to use. Next property is streak. This is where you take your mineral and we're probably gonna use tile, but you drag the mineral across it, and sometimes the powder form that falls off and streaks the actual tile is not the same color as the mineral in general. And so a lot of times you'll pick up, say, like a gray or a black mineral, and when you streak it, it'll streak white. And so the inside of that mineral may be a different color than the exterior. Luster. This is how light is reflected. So if something usually is described as having like a metallic luster. If you shine light on it and it looks metallic, that is one type of luster. We'll get into more like what is translucent, all of that when I get back. Here's the metallic luster. This is pyrite, once again, fool's gold. You can see where it looks like a metal. Crystal form. Crystalline form is so important. You can look at the actual mineral and see the crystal shape on the inside sometimes. Quartz has great crystal form. It's very visible, really easy to tell. Other ones a little bit harder. There you go, quartz, great crystal form. You can see that. Okay, hardness. It's the resistance to being scratched. Some of these things you're going to be able to scratch with your fingernail, and other things like a diamond you're not going to be able to scratch at all. And we use the Mohs hardness scale, which is on 1 to 10 for who's the hardest. Okay, I'm running out of time, so I got to make you another video. Be right back.